So in this session, we'll study about networking and the sockets. So till now, we have been writing programs on our machine, which can be a laptop or a desktop. But what if we want to make our content available to a larger audience? Probably we have to host our content somewhere on web, and then large number of clients in the form of browsers will connect to the server and view the content. So networking is the core of this. So what happens typically is that when your web browser requests for any web page in the world, for example, google.com, the web browser will create a socket. So web browser is nothing here but a form of client. So whenever we talk of networking, we talk of one server where the content is hosted and one client which tries to connect to the server to download or view the content. So in our cases, normally the web browsers are serving as client. So these web browsers create a socket and instruct the socket to connect to the web server which is hosting the website. In our case, we can also consider a Python website if it's hosted using Python. So the web browser client creates a socket object, and that socket object is instructed to connect to web server, where the web server is also listening on a socket for incoming requests. So basically now, what is socket? A socket is nothing but a network connection endpoint. So socket is specified by a combination of a IP and a port. So this unique combination of an IP and port defines a particular network connection endpoint. So in a short summary, the server binds to a socket. So basically server binds to a combination of IP and a port, and then it tries to listen to the incoming connections, and it's basically waiting to receive an incoming connection. In the case of client also creates a socket object and tries to connect to that socket on the server. Once the connection is established to the sockets, the two sides use the sockets to send messages and other data back and forth. So once the connection is established between a server and a client, then the two parties can actually communicate with each other. When in use, each socket is bound to a particular IP address and a port. So IP address we have already seen normally. It's a sequence of four numbers and IPv4. And the four numbers range from 02 to 55. That's an example 173.15.20.201. Port numbers range from 0 to 65535 usually. We have to be cautious that port numbers less than 1024 are reserved for well-known networking services. For example, 80 is used by HTTP, 443 is used by HTTPS, etc. We can also find the maximum reserved value for this in the socket modules IP port underscore reserved variable. So other port numbers can be used by us for our own programs. There's a special address 127.0.0.1, which is the local host address. It refers to the current computer on which you are working on. Programs can also use this address to connect to other programs which are running on the same machine. So the example which we'll take is right now I'll be hosting my server and client as two separate programs on same machine. So my host will be localhost and I'll use any particular port after 1024. So if we want to host something on the same machine, we can use localhost, which is nothing but 127.0.0.1 IP address. Now, what are domain name servers? So this is very interesting that, of course, you can always connect to a particular server if you remember its IP. But remembering more than a handful of IP address is usually tedious. It's in similar fashion that let's say you have 500 friends, you cannot remember the mobile numbers of all of them, so you feed them and fetch them via their names because names are easier to remember. Similarly, by paying a small fee, we can register a host name or domain name for a particular IP address. That is why you type google.com and the domain name servers identify the mapped IP and the connection is established. It's always easier to remember google.com, yahoo.in, careeranna.com, etc. So names remembering make your life easier. Now there's one more thing, that when sending messages between two programs, we usually choose between the protocols, so either a TCP or a UDP protocol. So we'll try to understand that what are the major differences between TCP and UDP. And my sample example, we'll do the socket programming through TCP only. So TCP creates a persistent connection between two endpoints, and the messages that you send are, number one, guaranteed to arrive at destination, and number two, they are guaranteed to arrive in order. However, UDP is connectionless, a bit faster, but it's less reliable. Less reliable because messages you send may or may not make it to other end. There's no guarantee. And of course, if they make it, there's no guarantee that they will arrive in order. So they can basically arrive out of order also. So occasionally, even you can see more than one copy of message makes it to receiver, and the receiver has to be really intelligent to do all such filtering, manage all the sequences. Uh, so we'll be using TCP in our session here. Now we'll see the design of server and client inside Python. So this functionality is provided by socket module. So first thing that we do is import socket. And as a step one, server creates a socket object. So inside socket module, the function to create socket is also called as socket. So we import socket and then we create s as socket.socket with first argument as socket.af underscore inet. This signifies that we are going to use IPv4 addresses. And second argument to the socket object is socket.sock underscore stream, which signifies that we are going to use the TCP protocol. So this would differ if we were using either IPv6 or UDP. Now, after the socket object has been created, the socket tries to bind itself to a given host and port. Syntactically, we use a tuple here to specify the host and port. Host is first argument and port being second argument. And once socket has been bound to a given host and port, then socket.listen specifies the maximum incoming connections that the server can receive. So this will also define how many maximum connections can be queued at a given point of time. After all these three steps have been done, then s.accept is the blocking call on server side. So basically it's waiting for the connections here. And if we now look at the client steps are easier and simple. First it creates socket object similar to server, and then simply the client calls the socket object connect method on the given host and port. Once it calls the method on the given host and port, the connection is established to a specified host and port. Show it shown in the yellow line. And then this blocking call is resolved. This blocking call accept returns con and address. Con is the connection object, and here as this the object. So after the connection has been established via socket programming, the communication can start between server and client. This will use con.receive and con.send, and here client can use s.receive and s.send to do the communication. After the communications has been done, client can shut it down by s.close, and server can shut down a particular client by con.close, and in a loop it can do shutdown for all the clients by using the same con.close for all. So we'll now see how to program this in form of two separate files, and how to do a small connection and small message exchange between server and client in a short while.